Okay, so today's 5 brief properties of operations. So I think you've probably seen these before, and you've probably heard of them before, but we're just going to talk about them again just to refresh your memory a little bit, okay? So I have a few definitions here for you, okay? Now I know it's a lot to write, but here's the deal. You either need to write this column or this column. You don't need to do both. And if I were you, I would write the examples with the numbers, if that makes sense. So let's not even worry about this one right now. We're going to talk about commutative. Have you heard of commutative property before? All right. See, I knew you've heard something about associative property before. Okay. So first thing we're going to do is I want you to write down this chart. Okay? And then after that, I'm going to explain to you easy ways how to remember these two things apart from each other. Because if you're like me, commutative and associative, I don't know which one is which. A lot of times I get confused. So I'm going to teach you an easy way to remember the difference between the two. Okay? And if you look, we're only doing addition and multiplication today. So you're always going to be using a commutative property of addition or commutative property of multiplication. Only using those two things. So I'll let you write that stuff down and then I'll talk more about it. Yep, go ahead and write associates down. Yep. So what's the only difference that you've noticed between the commutative property of addition and commutative property of multiplication? What's the only difference? Connor. Oh, I'm talking about these two. Let's talk about just these two. What are the differences between the top two? Right, one has multiplication and one is addition. Now here's the thing. Addition and multiplication are the only property, or the only, what do I want to call them? Operations that have these properties. And the reason why is this. If I look at 2 plus 6 and 6 plus 2, am I going to get the same thing? Okay, now what if I do this? What if I do 2? Oh my gosh, not again. Seriously, how come we just can't get it right? So what if I do 2 minus 6 equals to 6 minus 2? Is this the same thing? That's why, okay, subtraction, you can't use the commutative property, because guess what? You're not going to get the same number. What if I would do 2 divided by 6? Is that the same as 6 divided by 2? No, not at all. So that's why addition and multiplication are the only two operations that can use commutative and actually both commutative and associative property, because no matter what order I do it in, guess what? You're going to have the same answer. No matter, down here I have associative property and I have parentheses. See how my parentheses move down here? No matter what, I'm still going to get the same answer. Okay, so that's why addition and multiplication are the only two properties that work with these two things. Okay, does that make sense to everybody? All right, so let me give you some ways to remember these two things, because I know how many of us are going to say, well, I'm going to get these two mixed up. If I ask the difference between these two, I'm going to get it mixed up, okay? And I was the same way when I was in school. I never knew a good way to remember them, so I'm going to give you a good way to remember these two, okay? So I'm going to start with commutative property. What's going on in that commutative property? What happens? What's going on up there? What did I do? Yep. Okay, so see how I just flipped them? So I know that 2 plus 6 is 8, and I know 6 plus 8 is, or 6 plus 2 is 8, right? So here's a good way to remember it. Let's pretend that we're a community, and we really are, right? We're a community in here. Let's pretend that I take Josie and I move her back there, and I take Zane and I move him over here, and I take Kaylee and I move her over there, and I take Ryan and I move him over there, and I take Merrick and I move him over here, and I moved everybody around. But are we still the same community? That's what this property is like. No matter what I did, you see how I moved those numbers around? They're still the same. That's how I remembered commutative property. Well, commutative even sounds like community. Okay? So no matter which way I move people, you can even think you're a classroom, no matter which way I move people, nothing changed. Okay? Does that make sense to everybody? Okay, so my second one, I'm actually going to need some volunteers. Cadence, Connor, Josie, you guys come up here. They had their hands up first. Okay, so we're going to talk about associative property. Now let's talk about this associative property. What do you notice about it? Not them yet, but what do you notice about the associative property? What does it have in it? Parentheses. It has parentheses in it. So let's talk about this property. Let's say these three are three best friends. Okay? Three best friends. And they decided that since yesterday was early out, that they wanted to walk down to Pizza Ranch and they wanted to eat for dinner. Okay, so that makes sense, right? You guys are, all right, let's go eat pizza. Okay. So they start walking down the street. They start walking on the sidewalk, but guess what happens? They notice that the sidewalk is only big enough for two people, not three people across. So Cadence, guess what? You're going to have to walk behind them. Sorry. So now we have two walking in front, and then Cadence is in back. Okay, not a big deal. They go down and they eat. Oh, they're so full. They got to walk back now. But guess what? That sidewalk's only big enough for two. So Connor says, I'll be the one to walking back this time. Cadence can walk in front. Okay. Now tell me how this is like the associative property. What happened? Okay, I can put them in any order, but what do these two people represent? The parentheses. I can have no matter what, I can have two different things in the parentheses, but do I still have the same three group of friends? Yes, that's how I remember associative property. Does that make sense? So the parentheses act like the two people in the front. The thing in the back is Connor, I guess. Okay. Does that make sense to everybody? Okay, you can sit down. Thank you. Help you guys. That was awesome. So does that make sense to you? At the beginning, let's look at this one. It's like, who are my two front? The Connor and Josie were in the front, and there's my Cadence walking in the back. On the way home, here are my, I don't know, who is it? Josie and Cadence then, and Connor walking in the back. It's the same thing. Isn't that kind of cool? Okay, so that's the easy way to remember. Always too, associative property is the only one with parentheses. It's the only one. Today, anyway. Yeah. Sure. And that 5 on the outside, or yep, yep, exactly. It can go any way. Any of those two can be in there. But you've got the other thing too is you have to have the same two signs. Okay, so you have to have two addition. You have to have two multiplication. You can't have like an addition and subtraction. It doesn't work that way. They have to be all the same sign across. Okay. Questions so far? Not so bad. So what was my story about commutative property? Do you remember, Jasmine? Yeah, no matter where I put anybody in this room, we're all still the same people. And then this one, Pizza Ranch story. Okay? I can't tell you how many times like we'll talk about this in 8th grade, and I'll be like, "Oh, do you guys do?" Sure. Um, in 8th grade, we talk about this again, and I'll say, "Oh, does anybody remember my stories for these?" And they're like, "Oh, the Pizza Ranch story." So you'll remember it next year, I promise. I promise. What is happening? All right. So, there's a few other properties that you need to know today, and these are really, really simple properties, okay? You know what? You probably need to. We don't need to do this one again. That's fine. We don't need to do that one. Additive identity, multiplicative identity, and zero property. I don't think we're going to use much of these today, but it's good for you to know about them because I'm afraid they're going to show up somewhere. I'm afraid they're going to show up somewhere. Additive identity, multiplicative identity, and actually you can even call this the zero property. If you want to call this the zero property, I'm okay with that. That makes it easy. Additive identity, multiplicative identity, and zero property. And these are actually 3 of the easiest properties, but a lot of times people get these confused. You hungry now? She said I was hungry. I'm talking about pizza. Who may not be hungry? Thank you. So additive identity, multiplicative identity, zero property, or zero property, zero is fine. Okay, so if I asked you what's your identity, what would you tell me? If I say, hey Henry, what's your identity? What would you say? Okay, you'd say your name, right? Now, I would as well. What's your name? Well, my name is Amanda, yada, yada, yada. But look at these. Why do you think we call these the additive identity property? Why do you think we call this one the multiplicative identity property? Why do you think we call it? Because it pretty much shows its identity. You're right. Because look at what's happening here. 9 plus 0, well, what's my answer? 9. Do you see how 9 is still showing its identity after the equal sign? It's the same thing for this one. 5 times 1 equals 5. Well, that's also identity. And you got to know that additive identity, anytime you add 0, well, anytime you add 0, it's always going to be the same, right? Anytime you multiply by 1, it's always going to be the same. That's why it's called additive identity, multiplicative identity. Does that make sense to everybody? Okay. Now, the property of 0, well, to me, this is the easiest one. Because what's happening here? Anything times 0 is 0. So anytime your answer is 0, when you're multiplying by 0, it's called the zero property. A lot of times people will say this one's the zero property. Why do you think that? because you're adding 0. That doesn't mean it's a 0 property. That just means that you're adding, and it's going to be the same number, okay? So make sure you're careful with those. Yes? Well, I would say that would be probably an additive identity then, because if it's the addition sign in there, if it was 0 times 0, then it'd probably be multiplicative identity. So, or multiplicative, 0 property, sorry. So, careful. Even I make mistakes on these, so be careful on those. All right. Everybody good with those? Okay. All right, so let's talk about, I'm going to get rid of this one. Oops. I want to get rid of this one because we're going to talk about this one more tomorrow. So that's not even in today's. All right, so tell me, what property is this? Commutative. How do you know it's commutative? It's flipped. Okay, what about this one? Good. What about this one? Commutative. Well, why is this one commutative? It's flipped. Just flipped. Okay. So today you're going to have to be able to tell what they are. That's one thing you have to do today. And you can use your notebook. Yep. And then you can think of my stories. Well, I know that one. That's my Petrian story, so associative property. I know this one. Same spot, same spot, same numbers, same people, same letters. Commutative property. Okay. Yep. Not too bad. So I have a few more vocab for you. And my last vocab is actually counterexample. This is the last one I have for you. Okay, a counterexample is when you can prove something is wrong. So everybody who likes to argue, this is for you. I don't either. This would be Jack. So if you like to argue and prove people wrong, you will like this. You don't have to write the counterexample. We'll just talk about the counterexample, or we'll talk about this example. So a counterexample is proving something is false. And here's an example of that. If I came up here to you and I said every month of the year ends in Y. March doesn't. What else? December, August. You just gave me a counterexample. You proved I was wrong. Okay? Does that make sense? If I said every day of the week, I don't know, has an E in it. Monday doesn't. Sunday. Okay. You just gave me a counterexample. Okay. What if I said every even number is a multiple of 3? Why not? 18 is, and that's even. 2, 4, 8. Okay, you just provided me a counterexample. Okay, does that make sense to you guys? So a counterexample is telling you why I'm not right. It's basically saying, nuh-uh, because of so-and-so. Okay, let's see, what do I have right here? All numbers are prime. Ooh, let's do that one. Want to know what prime is? What's prime mean? There's more than one number that can go into it. So if I said up here, well, you guys, all numbers are prime. 3's prime. Composite. 18, there's how many numbers are going to 18? 16, 1, 4, 2, 8, 16, that's a good one. 50, there's a lot of 10. Okay, 100. So that's not true, right? All prime. What is this next one that I have here? The difference of two whole numbers is always less than the two numbers. The difference of two, what's difference mean? So the difference of two numbers, so the answer is always less than the 2 in the problem, is what it's asking. It is? Okay. Say that again so everybody gets it. Okay. 20 minus 5 is 15, and 15 is higher than 5. Even like 5 minus 1. 5 minus 1 is 4. 4 is higher than 1. See? So that's right. That's a good counterexample. Does everybody understand what that's asking now? Okay. That's what counterexample is. So what we're going to do today is we're going to simplify expressions. So we're going to do two things. You're going to have to tell the difference between the properties, and you're going to have to simplify expressions. So let me show you how this works. Okay? We're going to start with this. No, you probably just write an example down. Maybe to simplify, maybe. Oh my gosh. I'm going to have to redo this thing again. Why is this being a stinker this morning? People are watching my video probably thinking, what is she doing? Hopefully nobody watches this. Okay, so we're going to simplify expressions this morning. Okay, so if I look at this one, 4 plus 2 plus c, what can I do to put some things together here to make it as small as possible? What could I do, Henry? Yeah, let's put 4 plus 2 together, and that's 6 plus c. Okay, so see what's happening. Okay, what about this one? What can I do for this one to put two numbers together to make it as small as possible? You know? This is a tricky one. Cadence? 3D and 2D together? So how many D's do I have then? How many D's do I have? I have 5 D's plus 8. Right? So if you have the same letter at the end, like see I have these and these, those can be added together. And we'll talk about that later on in the year. I think they probably think you remember that from last year a little bit maybe. So that's why they put it in here. So anytime you have two letters or variables at the end, you can add those two together. You can't add 8 together. Why can't you put 8 with it then? Because it doesn't have a D on the end. So it can't be combined. Okay. Alright, so let's simplify this. This is what you're going to have to do in your homework today. So I have 7 plus G plus 5. And what we have to do is we have to use the properties that we just learned about to simplify this. So the first thing I need to think about is what numbers should go beside each other that I can add. 7 and 5, right? So what can I do to 7 and G? Can I flip them? So then I have G plus 7 plus 5. What property did I just use there? No, I didn't move my parentheses. I used my commutative property, right? Because did I just not flip 2? If you flip them inside the parentheses, that's okay. Did I move my parentheses completely, though? No. So I use my commutative property. Okay. Now, what am I going to do with my parentheses? Why am I going to move my parentheses now? So I can put 7 and 5 together. Does that make sense? I have to put them together to be able to add them together. So now, it looks like this. Okay? I have to have my numbers beside each other that I want to put together. And then I totally move my parentheses. So now I use the associative property. Now let's put them together. The end. So you're going to do things in steps today. You're going to say, okay, first I have to move these two things around because 7 and 5 have to be beside each other. Then I'm going to move my total parentheses because when I move my parentheses, what am I going to do? I'm going to add those things inside the parentheses. Then I'm done. Should we try another one? Let's do another. Okay, so I have 9C plus 8 plus 3C. So if I were you, I'd put an example in your notebook. Put an example in your notebook. 9C plus parentheses 8 plus 3C. What are the two things I need to add together up here? 9 and 3, right? So what am I going to do to put 9C and 3C beside each other? Let's flip 8 and 3. So we have 9C, 9, that's supposed to be a C. 9C plus parentheses 3C plus 8. And what property is that again? Commutative, very good. And then, what am I going to do with my parentheses? I'm going to take them and I'm going to move them. And that is associative. And then we can put them together. So they're going to ask you what you're doing today to solve the problems, what steps you're going to use. And guess what? Most of them are like this. So if you can do this, you can do your homework today. Let's see, do I have anything else? Anybody still need this yet? Merrick? Okay. I just want to make sure. I might change your homework assignment, so. Oops. Can we do this one? Sorry. Sorry. You're done. Okay, let's try this one. I want you to have this one in your notebook. So I have m, I'm doing times this time. M times 11 times m. So what are the two numbers that I want to multiply, or two letters that I want to multiply together up here? M and m. So I'm probably going to shift that m over, switch it. What do you think? So it looks like this, 11 times m, right? And that was commutative. Okay. And then I'm going to shift my parentheses. That's associative. Sure. Today you can, that's fine. That's fine. So then, what does m times m look like? Jacob? No, that would be if I'm adding together. Let's pretend that's like 3. What's 3 times 3? 9. Okay, what did I do to those m's? Okay, so what is it? What can that look like? What can I... Squared. Yeah, good job. So then this would be m squared times 11. Now, you can only do the squared part if you're multiplying. For addition and subtraction, you don't got to worry about it. Or for addition. But for multiplying, if you're multiplying two of the same things together, guess what happens? It turns into a squared. So careful with what you're making sure you know what process you're doing, addition or multiplication. You know what? I don't care if you kept it like that, but when you simplify something, they always want it down to the smallest answer possible, and this would be the smallest answer possible. So, no, I won't make you count it wrong. But just know that simplifying means getting things down to the smallest thing possible, okay? And that's the smallest answer possible. So, I think there's maybe only one of your homework like that. Any questions? All right, you want to give it a whirl? I'm going to change this up here, so.